you watched that video. Today we're starting R.6. There is a handout that's already posted. This is the handout for, we're working on the section today and Tuesday. So it's one handout for those 2 days. So that would be due then Wednesday. The other thing, I just gave you a study guide. After this section, we are at the end of the chapter. So we will be taking a test next week. Typically, I like to do a work day for the study guide, so I will see you guys on Wednesday, and that is actually what I have scheduled to be a review day. So you guys are lucky we'll have our review day in person. If it were me, I would probably start my study guide before then so you could ask me your questions while you're here in class, and then you guys will take your test next Friday. All right. Does that make sense, everybody? Any questions about that? So let's get out our notes then and start this section. So we started talking about radicals and negative exponents in the last piece. And we're continuing. This lesson is just working strictly with radicals and breaking those down. So let's just start off. We had some with fraction exponents in the last section. So I just wanted to make sure, if I give you that and tell you to write it with a radical, do you know how? So if I said 16 to the 3/4, what does that mean in radical form? What number goes outside the radical? 4. Yeah, the denominator there. That's called the index. So that's the little number that goes outside. 16 goes underneath. And then the 3 would go here. Okay, so if I want to simplify, fourth root of 16 is what? 2. So this is just 2 to the 3rd power, which is 8. All right, B. If I said the cube root, or sorry, I'm giving it to you. Negative 64 to the 2/3. Since the negative 64 is in parentheses, exponents touch what's directly in front of them. So directly in front of my 2/3 is this entire parentheses. So it's applying to everything. So what number would go outside my radical?
3 is the denominator.
Right. So cube root, so the denominator there. Negative 64 and then squared. So the cube root of negative 64, it's like saying what to the 3rd power is negative 64? If you don't know, how can you find it out? Okay, use your Chromebook if you need to, pull up that calculator. If you do the cube root,
Negative, that's not way it's right.
should be negative 4.
Yeah.
That sounds better.
If you type in, if you go to math, number 4 is the cube root, I believe. And then just type your negative 64 underneath it. Oh. So that would be a negative 4. That all came out of my cube root, so it's in parentheses. So I have to square the whole thing. If you take a negative and square it, it becomes positive. So that's positive 16 for our final answer. So if you get hung up on the numbers, you know you can use a calculator to help you there. All right. Let's go the other direction. So if I give you this and ask you to write it with an exponent. So the 7th root of n to the 3rd. That would be n to what power?
3/7.
Uh-huh. And that's all we can do there. All right, on B. So, how am I going to write this?
Would it be?
What do you guys think? Well, on the last one, everybody was quick to say the answer. So what's the problem on this one? What's different?
Parentheses.
Okay, the parentheses. Is anything touching my 15? No, so that just stays. These parentheses really make no difference. They can be there, they don't have to be there, it doesn't change anything. So it's the cube root of r to the 4th, so that's just r to the 4/3 power. And that's it. Now you would want to be careful if I wrote it, let's say I wrote it like this. You couldn't just write 15r to the 4/3 there, because the 15r was all underneath the radical. You would need to put parentheses around it in that case, because the exponents touch what's directly in front of it. On B, I only want my exponent to touch the r, but on this example over here, I would want my exponent to touch both the 15 and the r. Do you see the difference between the two? Okay. Let's start simplifying some of these radicals. If I wanted to simplify this, there are a couple ways we could do it. We could rewrite it as a fraction exponent, if we wanted. This would be z to the 6 over, what number is 2? On a radical, if there's nothing there, it's a square root. So you could think of it as z to the 6 over 2, which is just 3. Okay, you might also prefer just to think about the radical. If I have 6 z's, because it's a square root, it's asking me how many groups of 2 can you form. So if we have 6 of them, that would make 3 groups of 2. So whichever way makes the most sense to you is how you would go about simplifying that. So B, let's say I tried thinking of it in terms of those groups. S, you have 21 of them. It's a 7th root, so it's saying if I have 21, how many groups of 7 can I form? 3. T, if I have 7 t's, how many groups of 7 can I form? Just one. So it's s to the third t. Okay, c. Let's focus on just the number first. What is the square root of 81? Okay. R. If you have 8 r's, how many groups of 2 can be formed? 4. If I have 10 s's, how many groups of 2? 5. Let's try a couple more. D, we have to be a little bit careful on. It's kind of our instinct just to say those 4's cancel and we get -3. But if I were to work on the inside, if I simplified that first, if I took a -3 to the 4th power, if you put that in your calculator, you have to put the -3 in parentheses. So parentheses around your -3 and a 4 on the outside. What do you get? Positive 81. Now let's do the 4th root of 81. Do you guys know how to do the 4th root on there? You have to hit the 4 first, and then you go to math, and it's number 5. It's got like a little star and then the radical. That will let you do any kind of radical you want. And you get positive 3. So you have to be careful on something like this. When you take it to the 4th power, to begin with, it makes it a positive number, and it's a positive answer that we get out. E. Square root of 3x minus 4 squared. So this time I don't have to worry, I don't have like a negative here that would become positive when I square it. If you have a square root and a square, what do? Cancel one another, so what do we get? 3x minus 4. When things are multiplied together, you can do the square roots individually. If they're added and subtracted, you cannot. Any questions so far? Okay. We're going to just keep simplifying these. I do have a few properties of radicals. If you already know these, you don't necessarily have to write it down, but if you don't, you want to jot these down. If you have, this is what we were just doing on our problems. If you have a radical with things being multiplied, you can break it up and do each individual piece. The same is true for division. The third rule might be the one that you weren't familiar with. If you have multiple radicals, you can combine them into one by multiplying the index, the number outside the radical. I'm just going to pause this and give you a second to jot those down. Use them. Okay, if I said the square root of 6 times the square root of 54. Is 6 a perfect square? No. So let's try combining these two things first. If you want to put them together, all you have to do is multiply the numbers underneath. So take 6 times 54. And that's 324. Can you do the square root of 324? 18. So sometimes it's easier to go ahead and combine those things before trying to simplify them. Let's do, I think I'm going to change some of my examples here. I want to do the fourth root of a over b to the fourth. Okay. So it's division. What that means is you can do each of those things separately. You can do the fourth root of each piece. Can we do the fourth root of a? If I have one a, do I have enough to pull out a group of 4? No. If you don't have enough, it just stays underneath. Okay? On the bottom, the fourth root of b to the fourth, those cancel out and you just get b. So you might still have a radical left in your answer, and that's okay. You just simplify what you can. Okay, what if I said the 7th root of the cube root of 2? All right, starting on the inside, we want to see if we can simplify this. If it were like the cube root of 8, you could break that down. Can you do the cube root of 2? No, so I can't actually simplify it, but we could combine these so we only have one radical written. What do I do with the 7 and the 3? Multiply. 7 times 3 is, so we get the 21st root of 2. Any questions there? Are we doing okay with this stuff? We're just going to keep practicing, simplify a few more. A, the square root of 32. Is 32 a perfect square? Does that mean we can't do anything? What do?
You do the square root of 16 times 2.
Right. 32 is 16 times 2. So if we break it apart, the square root of 16 is 4. And then you have the square root of 2. B, I'm going to change this one. Let's make it more interesting. Let's do the cube root of 16x to the 7th y to the 5th. All right, 16, is that a perfect cube? Try it. Do cube root of 16 on your calculator. Do we get a nice answer? No. Okay, so we need to break it into a perfect cube. So perfect cubes, things to the 3rd power. 8, 16 is 8 times 2. Cube root of 8 is 2. So that means a 2 comes out. and the other 2 would stay under the rabbit. Okay, if I have 7 x's, how many groups of 3 can we form? 2, so x squared comes out. Were there any left over? Yeah, if you have 7 of them, your 2 groups of 3 account for 6, so we have 1x left over, so 1x stays under the rabbit. Y to the 5th. If I have 5 y's, how many groups of 3 can we form? 1 group of 3, so 1 y comes out, and how many y's are left over? 2. So 2 stay underneath. So that is our final answer. Let's try, we're going to do a couple more. Okay. Cube root of negative 16. So what would I break a negative 16 into? We broke 16 into 8 and 2, right? So let's just do negative 8 and 2. What's the cube root of negative 8? Negative 2. So a negative 2 comes out. And we still have 1, 2 left underneath. If you have 4 x's, how many groups of 3 can be formed? 1 group of 3 comes out, so then that accounts for 3 of them, so we have 1 x left underneath. Are these going okay still? We'll do one more like this. This, if you can't tell, it's a big fraction. Okay. Can we do the 4th root of 16? Yes, what is that? So a 2 comes out. If you have 5 x's, how many groups of 4 do we form? 1 group with how many left over? 1 left over. If you have 15 y's, how many groups of 4?
3.
How many left over?
3.
3. Do you guys know how we're getting those numbers? On the denominator, if you have 81, can we do the 4th root of 81? That's just 3. So that is our final answer. Do we need more of these? Last thing I want to do today is just a couple examples with adding and subtracting, and then that's going to be our stopping point. You can multiply any radicals that you want, but in order to add or subtract, they have to be like terms. For radicals, that means it has to be the same number underneath the radicals. 12 and 3 are definitely not the same number, so I can't add these together yet. But we can reduce. If I have a 12, what could I break that into? 4 and 3. Okay, the square root of 4 is 2. So that's a 2 radical 3, but don't forget we already had that negative 8 out in front. So what do I need to do with my negative 8 and my 2? Multiply. So I have negative 16 radical 3 plus radical 3. When you add these, you're adding their coefficients. So this is like a 1 radical 3. So negative 16 plus 1, negative 15 radical 3. Let's do this one. Alright, can we break down a cube root of 2? No. What about 54? What perfect cube goes into 54? So perfect cubes, like 2 to the 3rd power is 8. Can you do 54 divided by 8? No. 3 to the 3rd is 27. Can you do 54 divided by 27? Yeah, you could do, it's 27 times 2. It is 9 times 6, but 9 is a square. Usually 1 cube. So we could break this into a 27 and a 2. Okay, the cube root of 27 is 3. So that radical breaks into a 3 cube root of 2. So what I have right now, we have this 5 cube root of 2 minus, don't forget there was a 2 out here. So we get to take 2 times 3 and you get 6 cube root of 2. So coefficients 5 minus 6 would be negative 1, or you could just write a negative cube root of 2.
I got lost.
Okay. Do you understand how we got the 3 cube root of 2?
Oh yeah, because 27.
27 is a perfect cube, and we knew we needed cubes because of the cube root.
Okay.
Then there was a 2 already out here, so I had to multiply it with the 3 to give me the 6 out in front.
Okay.
And then I just carried down the rest of the problem. One last problem. Alright, so I have 3 radicals. We're going to have to break down all 3. So if we look at the first one, can we do the cube root of 8? Yeah, that's just a 2. If you have 4 x's, how many groups of 3 come out? 1, so 1x comes out. How many are left over?
1.
Oops, that's a cube root right here. Okay. The cube root of negative x. This is like a negative 1x. Can you do the cube root of negative 1? Are you sure?
Just negative 1.
It's just negative 1. So a negative 1 could come out, and you have a cube root of x. Okay, what's the cube root of 27? 3. You have to multiply it with the 4, so we get 12 cube root of x. All of these have a cube root of x, so we can combine like terms. Now this first term also has an x on the outside. Do any of the others have that? No, so this one you can't add it with anything else. But these are both just numbers outside. So negative 1 plus 12 would be 11 cube root of x. And that is our final answer.
Wait, so at the end,
Mhm.
when the 27x, when you get the square root of 3, are you multiplying the square root of 3 or the exponent?
I'm multiplying the number that came out. So we had 4, and we essentially broke those two apart. Then the cube root of 27 was 3, so that 3 came out. And then that's where I got my 12. Any other questions? So we still have some time left. There is the handout I showed you, R.6 handout that's posted on Classroom. I posted it yesterday. This won't be due until next week because I have to finish the section on Tuesday. So when you guys aren't here, either join the Google Meet or watch the video after class. Right now, you guys can do quite a bit of these. You could already do 1 through 13 and then 15 through 17 if you wanted to work that far. But just take this time now and get started and let me know when you have questions.